Hey guys, so in this video, I'm going to show you how to use MathCAD. I know, I know many of you guys already know about maybe hear about heard about what is MathCAD. So the MathCAD is one of the biggest platform where you can solve typical numerical problems in maybe you can use for mathematics, physics, or any other your class. So let's start here. So in MathCAD, let me introduce you with the the important tab. So here we see the math here, and we have math x plus y like this tab origin, and we have also like solve block, chart block, and here mostly I mean when you use mathematics, let me use here. I'm going to suppose this is question number 1, and the question is about if if force is 20 Newton, 20 Newton, uh, and distance is 2 meter, then then what is the work done on the body, then on the body. So this is in the form of text formatting. So we can see here these are like text. It has everything. I mean, just like Word, Microsoft Word. If you go over here right now, I'm going to use the value like so. The first we need to define. To define this one, we need to go to this tablet, this tab operator. If you go operator, if you go down here, here's definition and evaluation. So we need to just define this one. So we know the force is 20 Newton here. Write the unit, and like here, so you see the unit is in blue color. And if you go here, I mean, if you just it gives me this value, F is equal to 20 Newton. And now I'm going to define distance. Distance D is, here, for example, we just have 2 meter. So we can just write like here, it's 2 meter. So work done is W, define W, and we know work done is force into displacement. Here displacement is just D. So we define this one. Now it can give the values. Same way, this is just I mean this is a very easy example. So if he goes here, down here, now I am going to change the values. Now I'm going to solve one of my my problem. So I mean my related to my problem, my field problem. I mean it's about semiconductor, the physics of semiconductor here. So let's go here. Suppose temperature is given. It's room temperature 300 Kelvin. How do I write Kelvin here? We can just if we can just type capital K, and if you go here, just T. If you just use this button, then gives you the value of T. Right now T is defined, and now I'm going to suppose number of. I mean this is the concentration of dope, concentration of uh, doped atoms uh, is is how much? Suppose it's like 10 to the power 17, 17 into it's number of atoms per cubic centimeter. So we just need to define like this one, and here we can do this. Come add like this. Then it puts the value. You see the it's given this is L. So L is basically it's saying like it's a normal like meter, you know. Let me write cubic centimeter. So right now it's same. If you change, I mean if you want to write in cubic meter, then look at how much it's gonna be. It's gonna be like 10 to the power 23. You see, it's 23. So now we have ND is equal to this. Suppose, for example, I'm just showing you how to use. I mean how to use MathCAD. Suppose this semiconductor is N type. So MD is the number of doper. I mean the the impurity atoms like dopant. We call dopant. That's MD is equal to 10 to the power 17, and here we are going to use so and suppose this semiconductor is what? This semiconductor is silicon. So if you write like silicon, you just subscript like this. You need to define like this. And we know this is the majority carrier is here. We have electron. What we have? Electron basically. So we can write this D. I define this one as this. Now this one gives the value of this. You see, it gives in the value of meter. And now I'm going to change the value in cubic meter. So this is so, and we know what we know. This is uh, the concentration of I mean this is the concentration of the intrinsic semiconductor. So we have, I mean, it should be given. For example, I think I'm not sure exactly, but I'm going to write this as 9 into 10 to the power 9, I think maybe. I forget the exact value, I think. I'm not sure, but it should be like 9 type. So its value is 7 cubic centimeter. So Ni is equal to It gives same like this. If you type in centimeter cube and value in centimeter cube. Right now we need to find the concentration of the doping concentration of the holes. For this, what I'm going to do is for silicon. So basically the formula is Ni square. It's Ni square. You see, if you write like this, it doesn't work. Maybe you should. Let me see. Let me see. So Ni square. Oh, here it's gonna be divided by ND. ND. Look at here. This gonna gives us. Okay. So this is the. I should type like this. It should be. That's a very less, I think. Maybe the power is, I think, 10 to the power 6, I think. So I think you guys understand, how it works, let me show you something. If we define these ports here, and if we put these values just ahead of this, top of this, then we'll get the error. Let me see the error. This is right now it's defined. I think that's why this is given here. But I'm going to show you here. Don't worry. Here I'm going to show you. Let's define this. Oh, let's see this value. What this value here. Because this is already defined, that's why we are not getting error. Now I'm going to show you how we get the error. So what are we going to do here? Maybe we can use the other equation, I think. To find the built-in potential, to find a built-in potential for the silicon. So this is the equation. Right now I'm going to write this equation. To write this equation, first I need to define the value of K. The K is here Boltzmann constant, and the value of the Q is a charge. Here we know the Na and Nd. Let me write this one here. Suppose this is K. Small k is defined here as Boltzmann constant. And I hope you guys know the value of the Boltzmann constant. Its value is almost 23 10 to the power 23 joule per Kelvin. So joule per Kelvin. Write like this, just go like this. You see, this is MKS unit. Maybe I hope you guys know about MKS system of the unit. Here I'm going to write SI unit. So to write an SI unit, just like what we have here, go to here. I see. I know I already defined this, but here I'm going to show you how we get the error if we don't define the value of So we know the value of the charge here, electric charge. Find the value of the electric charge. It's minus 19. Column. Column is capital K. Let me define here. Just I want to show you how we get here. You see, we see you see here we got the error. This variable is undefined. Check that level is set correctly. So we need to levelize this one. If you levelize this, you got the value same. Otherwise, if you define the value just top of the given definition, then we got the error. Now I'm going to find the built-in potential EI of silicon. So silicon, to write like this, we need to define the formula. So what is the formula? Do you guys know the formula? Maybe not. So its formula is K times T divided by Q, and K times T times natural log of Na multiply Nd divided by Ni square in natural log, and also we have Q here. So let me define this. So basically we have K into T to define Q. Here we have natural log. Natural log is what? Natural log we have here I mean the NDs. I mean here we don't have ND here. Yeah. So if we are given n, suppose I'm going to just use it. PSI we can use, but I mean we don't have n here. Let me define n. Suppose let me pull this to me down. Suppose we have given the number of concentration of acceptor atoms. How much? Suppose we have given, I mean, 10 to the power, I mean, like 14, just 14, because this entire majority carrier is here. What? Here we have electron as a majority carrier. So it's in cubic centimeter. Like we can write like this. And here we define this one. It gives in meter. We need to write in cubic meter or cubic centimeter. Now I'm going to N into ND, which is divided by Ni square. Ni divided by Ni square. Right? Now we are going to get the value of the GBI of silicon. So how much we got here values? I mean, we got a really large number here. You know why we got large number? Maybe because we have here N value is really big values. So the K over T, K multiplied by T over Q ln Na into MD Ni square. And maybe we can, I think, let me see. If we change MD as just as a P of SI, then maybe we can get the exact values. I mean, hold on. What the heck? Oh, I get you. You see where I made a mistake here? I put the small s. I need to put this one. Let's see the values. It's a 0 volt. I'm just showing you like how to function like this table. To use the symbol, we need to go over here. Sometimes we need to use the eta, maybe like new, psi, omicron, tau, chi, phi, pi, pi, lambda, zeta, alpha, gamma, delta, epsilon. And we have all symbol here, mostly what we need to use here. We have also constant value over here, like we have given pi, we have given electric charge. No, this is natural logarithmic, exponential. This is infinity, physics. And this is velocity of light or in vacuum. And this is electric charge, H. This is reduced Planck's constant, Boltzmann constant, molar gas constant, molar gas Redward constant. This is defined as like, and this is Avogadro's number, atomic mass unit, gamma. This is Euler's constant. This is epsilon naught, mu naught, Stephen Boltzmann constant. This is magnetic flux quantum. So basically we need here, if you want to use the unit, you see the BQ is less than, and we have all values. TMS, radian, like capacitance, like these. We have majority of unit given here. You see, base unit. You see, base unit is like, base unit. It's like MKS unit. CGS, you see, it's in SI unit. If you want to write like this, here everything is like this. So hope you guys understand how to use MathCAD. Thanks for watching, and in next video I will do more exercises. Thank you so much.